Alright, welcome to add two numbers. So we are given two non-empty linked lists representing two non-negative integers. The digits of these integers are stored in reverse order, and each of their nodes contains a single digit, and we should add the two numbers and return the sum as a linked list, and also a linked list where the digits of that sum are in reversed order. But don't worry, let's take a look at this example and see why is that. So the first list is 2, 4, 3, null. So the number, because the digits are in reversed order, is going to be 3, 4, 2. So the first one is 342, and we should add this value by 465. 465. When we add these two numbers, what do we get? 2 plus 5, 7. 4 plus 6, it's 10, so we write 0, and we have one, other unit. 3 plus 4, 7, with that unit, 8. So it's 807, which in reversed order is going to be 708. So that's why the result is a linked list 708 and then null. Cool. So the first thing that might seem a little bit odd in this problem is not only that, the numbers are stored in linked lists, but why are the digits stored in reverse order? Well, actually, that is for our own benefit. Because as you can see here, when I have the numbers and when we add two numbers, the algorithm that we have learned in, primary school, is that we start with the last two digits of them, add them, get the result, eventually a remainder, then move to the left, and add these two digits together, and so on and so forth, right? So basically, in our little algorithm, we traverse the digits of our numbers from right to left, from the most insignificant to the, most significant one. This is why the digits are also given in this order, so that when we want to, traverse the numbers, we can start from the heads and always move to the next links, and so on and so forth. Now, obviously, these two numbers won't always have, the same number of digits, so these two lists will not always have the same size, but for now, let's think about the scenario in which they have the same size, right? Let's start small. The algorithm is actually pretty straightforward. We only have to simulate the addition algorithm that we've learned in primary grades to the linked lists. So we always need to know what are going to be the digits that should be added up together. And because now the digits are nodes, we need something to point to that nodes, right? So initially, because we want to deal with the first nodes, I'm going to have a pointer, node 1, which is initially the head of the first list. And I'm going to have also a pointer node 2, which is going to be the head of the second list. Awesome. Now, what's going to happen is that, of course, as long as node 1 and node 2 exist, they are not null, so we basically get out of the list. I'm going to add these values together, and I get a 7 here. So I need to create a new node, which will store the value 7, and also because this is the new node, this will be the head of our solution list. Cool. Everything's fine. I have the digit 7, so I move on. Now node 1 is going to be equal to node 1 next. So we move upon the link. This is the new node 1. And also this happens for node 2. Now we have this node 1 and this node 2. What's happening is that again, we will add this together and we get 10. Now, of course, I'm not going to create a new node with the value 10 there because 10 is not a digit, but let's remember what do we do in this type of scenarios in our addition algorithm. What happens is that we always remember somehow that we have a carry. There is a unit that should be carried until we find the right position, the right place to also add it, right? So I'll also have a variable here, carry, which will initially be equal to 0. After I've added these two, I see that I get a 7, which is a digit, so carry is still 0, I can write the value here. Now, I have 4 plus 6, which is 10, and because 10 is not a digit, I'm just going to use its last digit, which is 0, so I will create a node of value 0. I'm gonna link it to the previous node, of course, and now the carry is 1. I know that I should carry this unit with me until I find the place where to add it. Now, we move to the next nodes. So node 1 moves here, and node 2 moves here. Awesome. Now, what's going to happen is that I will add 3 plus 4, and now plus this carry, so I get an 8, which is a digit, so I can just create a new node, which stores the value 8, and of course link the previous node to this node. Then move again one more step to the right. Node 1 becomes null, node 2 also becomes null, so our job is done, and we have just to return the head of our solution list. As simple as that, guys. Only thing we have to do is store these 2 pointers, store the carry variable, and at each moment of time, add the values in the nodes along with the carry. If the sum is a digit, create a node with that value there and link the previous node to this node. If it's not a digit, create a node but with the last digit of the sum there. Link the previous node to, to this node and set the carry to be now 1. And that's it. Then you move to the next steps with node 1 and node 2. As simple as that. Now this is how we should solve the problem if the numbers have the same length or if the linked lists have the same size. But let's analyze what happens when a list is greater than the other. And I've taken this example. Basically, I have to add 99 to 999. I really love this example because not only that the second list is greater than the first one, but we are going to have a lot of carriages. So 9 plus 9 is 18. We store 8. We remember the carry. 9 plus 9, 18. With the carry 19. We write 9. Remember the carry. 9 plus the carry is 10. So we store 0. Remember also the carry. And then even if you don't have any digits, you write the carry. We need to make sure that this is how our algorithm operates. So let's simulate it a little bit. Of course, I'm going to start from here with node 1. And from here with node 2. And of course, my carry is going to be initially 0. So what happens? Well, let's add 9 with 9. I get an 18, which is not a digit. So I will create a node with its last digit, which is 8. Set carry to 1. And because this is my first node, this is going to be, of course, the head of the answer list. Now, everything fine. Let's move to the next node 1 and also to the next node 2. And of course, add them together. 9 plus 9, I also get 18, but with the carry, it's now 19. Because 19 is not a digit, I'm going to create a new node which stores its last digit, which is 9. Now, I'm going to link the previous node to this one. And of course, carry will remain 1. Perfect. Let's go to the next step. I'll move n1 to the right. I'll also move n2 to the right. And this is the interesting part. As you can see now, n1 became null. So what should happen here is that we don't have a digit. Let's get back to this example. When we didn't have a digit here, we could suppose that that digit was actually a 0, right? That's basically what we did. 0 plus 9 plus the carriage was equal to 10. So no problem if n1 is null. I'll just suppose that I have the digit 0 there. If n2 is not null, I'll add 0 with 9 and I get 9. With the carry and I get 10. 10 is not a digit, so I'll create another node with the last digit, which is 0. I'll link the previous node to this one. And now the carry remains 1, as 10 was not a digit. What's going to happen now? Well, because n1 was null, I'm not going to move it to the right. It's already null. I know I don't have a digit there. But I'll move n2 to the right. And now n2 is going to be null. Awesome. On the next step, n1 is null, n2 is null, so I should definitely stop. Because if I don't have a digit at least in one of these numbers, that's the end of the algorithm, right? Yes, it is. But we should also be careful. There is one more final step to do here. As you can see, our number is 098, 98 kind of. But the number should be 1098. Why is that? Because we have the carry. This is exactly what we've done here. We've written 0 then we had no digits, but we checked the carry, and if it was 1, I will write 1. So in the end, I will also check if the carry is 1, and if so, I'm going to create one more node equal to 1 and link the previous one to it. And that's it, guys. Now, let's say the first list was greater than the second one. It's the exact same thing. At some point, n2 would have been null and n1 would have still be valid. That's cool. If n2 was null, let's suppose I have a 0 there and add the digit from n1 to 0 also to the carriage and continue until at some point both of them, n1 and n2, are null, at which I will just check the carry to see if I need to, create an extra node. And then I will just return the final linked list. Let's see how the algorithm looks like. Alright, and here is the code, so please don't get too scared. I know it's a little bit heavy, but we are going through each and every line of code and you will understand it in the end. That's a promise. So, I use my pointer node 1, which is initially equal to the head of the first list. My pointer node 2, which is initially equal to the head of the second list. And my carry, which is initially equal to 0. Cool. Now, I use another variable head, which is initially equal to null, because not only I want to create the answer linked list, but also return it. And by returning it, I need to return its head. So that's why I store this variable to remember the head. And as you can see, I return it here in the end. I also remember the tail, which is the current last node of our answer linked list, because when I, create a new node, I need to link the last node from the list to that new node. So I always need to know the tail. Cool. Now, while node 1 is not null or node 2 is not null, so at least one of them is not null, I have first to compute the digit sum. And because we take carry into that sum, I'm just going to initialize it with carry. Then I'm going to add the digit in node 1 and add the digit in node 2. What happens here is that because node 1 or node 2 can be null, not both of them, but one of them can definitely be null, I've written a function to not have duplicate code to check also this scenario. So, digit sum and node. Inside the function, I check if node is not null, and if so, I add the digit in that node to digit sum, and then I move the node to the next node. Be very careful, these two variables need to be passed by reference so that the changes that occur inside the function will also be available here after the function finishes execution. Cool. Now I have my digit sum. If digit sum is greater than 9, well, I'll set carry to 1 and I'll decrease 10 from the digit sum, right? Else carry equals 0. So, for example, let's say, I had carry equals 1, right? And my digits were maybe 9 and 9. What's going to happen? 1 plus 9 plus 9, that's 19. So what I need to do is make sure that carry is 1 for the next step. So set carry to 1, it's already 1, that's cool. And decrease the digit sum by 10. So now here I only have 9. I know that I have a carry for the next step. Here I have 9, so 9 is the digit that I should store in my next node. Also, there is one more thing that's interesting here. Let's say that carry was 1, but I had the digits 2 and maybe 6. 1 plus 2 plus 6 is 9. So digit sum is less than or equal to 9. So be careful, carry should be set to 0. It was 1 previously, but make sure you set it to 0 so that you don't carry that unit without obviously not being able to use it, right? Or shouldn't use it. Okay, now, I know I should create a node with the value digit sum inside it. And what should I do with that node? Well, it depends. If the head is null, so this is the first ever created node, then I should create the node and set it to be the head. And also, I made a mistake. I should also set it to be the tail, right? I always need to know the tail. So actually, head and tail are both going to be set to this new node. Cool. Now, if head is not null, okay, what should I do is that I should create a node with digit sum and set this node to be the node that comes after tail. So tail next is this new node. And then of course, because right now I've created a new node and the link between tail to node, I will also set tail to tail next to point to this lastly created node. In the end, after all of this happens or finishes, I should return head. And actually, I realized right now that I forgot to do the last step, which was, after finishing the while loop, after it finished execution, I should actually check if carry is 1, and if so, create the new node, right? So let's just write the code here. So if carry equals 1, what I should do is that I should create a new node, right? And the value in that node is definitely going to be 1. So let's just copy paste this. New node of 1, right? Awesome. And then I should link the tail, right? The lastly created node to this new node. So tail next is actually going to be equal to new node of 1. Okay. And I think that's it. Yeah, I think that's it, because this is the last step. We don't need to update the tail because we don't care about it. And then we can return the head. Yeah. So this piece of code will come right after the while loop finishes execution. And now this is the whole algorithm, guys. Let's analyze the time complexity. As you can see, every operation that I do here is constant. I make assignments. Of course, I have a while loop, assignments. Then I call my function addDigit, which, as you can see, runs in constant time. And then some checks and assignments and creating a node, which is also constant. So the real question is, how many iterations does the while loop do? Well, the while loop basically runs as long as node 1 or node 2 is not null. So if we denote the number of nodes in the first linked list by n and the number of nodes in the second linked list by m, of course, this while loop is going to perform at most n plus m iterations. Think about it. Node 1 starts from the head and always moves to the next, and node 2 also. So the time complexity of this algorithm is definitely big O of n plus m. Now let's think about the space complexity. Well, in this algorithm, we actually use a new list. We create a new list, which will hold the digits of, the addition, the result number. So the real question is, what would be the maximum size of that list? Well, a worst case scenario is pretty easy to imagine. Let's think about it like this. I have 9, 9, 9, and so on and so forth, only 9s, right? Plus 9, 9, 9, 9, 9, only 9s here. Let's say they have equal size, these two lists, and I have, n 9s and m 9s, right? What's going to happen here is that 9 plus 9, 8, and I have a carry. 9 plus 9, 18, with the carry 19, and I have another carry. Then 9 also carry, 9 also carry, 9 also carry, and then I only add a new digit. So as you can see, the number of digits that the result number would have is at most the maximum between these two, n and m, plus 1. So we can say that the space complexity is, I can say big O of n, but it also could be something like big O of m. So it is actually, to be like very specific, big O of the maximum between n and m, right? Because if n is 1, I have only one digit here, and m is, 1000, then definitely m is more important. So yeah, these are the time and space complexities. Now, of course, you can improve the space complexity. You can even have a constant extra memory used if you manage to create the result number in one of the lists. For example, store its digits in the first list, L1, or in the second list, because you already have that nodes. So yeah, you definitely can do that, but this is not the point here. The point is to really understand how to work with linked lists. This is it, guys. I hope you enjoyed it. And as always, I'll see you on the next one. Bye.